Earth was ruled by the dinosaurs. They lived all over the globe and ranged from the size of a small chicken to the largest animals to ever walk the earth. Millions of years later, thanks to our wonderful technology here at Cicada Genetics, the dinosaurs are reborn once again. But how is this possible? Well, here in your first staff orientation tape, you will learn about the cloning of prehistoric life. Introduction to Darwin. Darwin was originally used as a diagnostic technology for genetic disorders. However, it was later discovered that it could be used to observe microscopic imprints of DNA on well-preserved fossil remains. The first step of this process is the imaging stage. Darwin uses advanced microscopic imaging to produce clear micrographs of DNA. These are then analysed by Darwin's artificial intelligence module. The AI looks at the micrograph and infers the nucleotide sequence of the target DNA strand based on each nucleotide's individual morphology. This sequence is then synthesized in the fabrication stage. A separate Darwin module loaded with the appropriate components such as free nucleotides and the correct enzymes can artificially synthesize the analyzed genetic material. The result of this process, fragments of paleo DNA from animals lost to time. However, fragments of DNA alone can't create a living animal. That is where genetic combination occurs. We use the DNA of related species to fill in the gaps in the target's genome and allow for an embryo to be produced. But this is not without great challenges.
This is a Dilophosaurus embryo. It did not survive the incubation process, unfortunately. We think this is due to faulty enzymes, but this will be corrected in future iterations. This is version 10, and I believe very soon we will have viable Dilophosaurus embryos for the lab.
As seen in our demonstration, it may take many iterations and revisions to produce viable embryos. Then once they are produced and placed in artificial eggs or wounds, the resulting animal may still actually look very different from how they were in the wild due to the nature of gene combination. Now, is it getting pure?
It's almost perfect. This is the purest we have for this genus. 91%. We changed some of the bird DNA we used, but this is the best look at the Dilophosaurus we have. We started to incubate one, -30-1, first of its batch. It shows no deformities like the others. It seems this time we may have actually succeeded.